If there's no questions on the assignments, what we're looking at today is the graphs of sine and cosine function. And sine and cosine make a wave of sorts. Because they look like this here, they're going to be reciprocal, not reciprocal, but are cyclic functions. They repeat themselves over and over and over again. And our one in blue is our cosine function. Let's get a pen. And the one in red is our sine function. And they repeat over and over and over again. Now, the amount that they repeat is 2 pi. For blue, for cosine, as we go here for pi over 2, we come all the way down for pi, back up, and for it to do one complete cycle, it's taking it a distance of 2 pi. So for just the cosine function, it takes 2 pi to complete one full cycle. Now for sine, because we start here at 0, we come up and down, and it looks like it goes one full cycle at this, but it's not, because it goes back down and then back up. And again, for sine, to go one full cycle, one full period, it is still 2 pi. Kind of make sense so far? And it's also why the unit circle is goes all the way around 2 pi, or 360. Because all they did to get the unit circle is they took these two and kind of folded them onto themselves to make a full circle. And the y values are still going between 1 and -1, our range for both of these between 1 and -1. Now there's kind of 5 key points if we were going to graph it, and I'm not going to make you graph any of these. We always look at the intercepts, the maximum and minimum points, the highest and lowest, and where it crosses the x-axis. Because for one period for cosine, we have 2 maximums and kind of a minimum at the halfway point. And we have 2 spots where it crosses the x-axis. And if we use these points, we can get an idea of what the sine or cosine function looks like. Because for sine, well, it intersects the x-axis at 3 points. Along it, we have a maximum and minimum point for our overall function. But also, our graphing calculators can graph these for us. The TI-30X or TI-84 will graph them. Now, whenever we graph these, all we've got to do is hit y equals, because this here will graph the function. And we could say sine of x and hit graph. Well, we'll need to zoom it to make it look a little bit better so we actually get an idea of what this function is. And as we scroll down here for the different zooms, we have z decimal, zoom squared, zoom standard, z trig, zoom for the trigonometric values. And if we hit enter on this here, it'll change the values along x so that they actually make a wave function. So we're looking at more of the trig values. Because if we look at the table, as we have these here, but it's set up, or let's look at window, in such a way that it scales it proportionally for us. So it makes the scale look better and look more accurate to what we're looking at. So we could look at, say, 3 sine of x. So it increased it by 3. The amplitude, we could change the period of it, because we could say 8x. And look at the graph of this. So now it's increasing faster, or we can increase it slower. So we can do different things with the overall function. Now, both of these functions here have different parts to them. One of them will make sense for sure, and that's the value of k for both of these here. And this here is our vertical translation. K is the vertical translation, and it's the same for both. Really, all that's telling us is moving the function up or down. It's going to move it up or down. A is our amplitude. And this value, this amplitude, is going to be the amount that we increase from the center of the function. Now, for most of our sine and cosine functions, I'll look back at this here, they're talking about where it cuts to the center. So for this here is the x-axis. And the distance from the center to the maximum point is 1. Center to the maximum for here is 1. The same is true for cosine. Now, if we look back at this graph, I'll remove the 8, and we say 3. Well, now the distance from the center down to the lowest and highest points is a distance of 3. It's that amplitude. And if the A value is negative, it's going to reflect across the x-axis. Now that leaves us with the bx plus h. The b value is where we get our period from, or we get the period of the function from. Now, this here, and it's in the next slide also, the period, the amount of the actual period is going to be 2 pi over b. So if we want to know what the period's amount is, we take it and put it underneath 2 pi and simplify. Questions on this here so far? And the last part is the h. Now in Algebra 2, when we talked about this here, we talked about it as a horizontal translation to the left and right. For this here, we call it a phase shift. Because again, since this is a cyclic function, it's a repeated function going to the left or to the right, it's going over and over and over again. Because unlike the functions we dealt with in Algebra 2, where we just had a graph, a quadratic, a U-shaped graph, we moved it to the left or to the right. But with a phase shift, we're moving all those points, so they're going to a new spot. So we don't really talk about it as a horizontal translation, it's a phase shift, because we're moving the whole thing. Now the phase shift is going to come in the amount of h over b. H over b. And something in the back of my mind is telling me I wrote these wrong. Yes, I knew it. I'm going to do this with a nice little trick. But we need to cross both of those pluses out and make them into a minus. Yeah, because that needs to be a subtraction. And part of the reason I knew that is every single time we have something in a set of parentheses with these general forms, it's always going to be a minus. There's very rarely that we'll have a plus, especially if we have something in parentheses for a general form. Now the phase shift is h over b. And the reason for this is because the period's value is affecting the overall phase shift, that it's moving left or right. So if we really want to see what that is, I'm going to erase this here. What we're really looking at is, erase over the top of this here, is we end up taking and factoring the b out of both of these here. So we end up with b times x minus h over b plus k. To figure out what the real phase shift is, we have to pull whatever that amount is out of both terms. And what we end up doing is just dividing whatever the b term is by h to get the phase shift. And if it works out to be a positive value, positive plus h, that means h is going to be negative. Questions on this here? Now I included this here for you, so the amplitude is just going to be the absolute value of a. Because whatever a's value is, we take the absolute value of it, because again, just the a itself, its value itself, is telling us what the amplitude is. If it's negative, it's just saying it's a reflection across the x. The period is going to be 2 pi over b for sine and cosine. So whatever the number in front of x is, we divide it or put it underneath, take 2 pi and divide it by it, and it gives us our period. Note that when b is between 0 and 1, the period of a is going to be greater than 2 pi. And whenever it is less than 1 or greater than 1, it's going to be shrinking it. Because again, we're dividing it by 2 pi. We're making the amount it takes, or time it takes for it to repeat, is smaller. If it's a fraction, it's going to take longer. And c over b, they use c, h, or a, b, and c. We used h and k, or h and b. So it's taking those and dividing it. All it's saying is that when we looked at sine, cosine, and tangent, the start and end points, how far am I moving both of them, to the left or to the right? That's all that equation's saying. Questions on this so far? So if we look at this here, y equals sine of x over 2, and that's it. And for this here and the homework, this is all we're going to be doing. I'm not going to have you graph it, but I do want you to find the period, amplitude, reflection, phase shift, and vertical shift, if there is one. Well, looking at all these here, the reflection, is there a negative in front of sine? Well, no. Sine's positive, yes? So what that tells us for certain is that the reflection is none. There is none. There isn't one. It isn't being reflected either way. Because if there's a negative in front of the x inside sine, it's a reflection across y, the y-axis. Now the amplitude. Well, this is again a sine of dx minus h plus k. Well, the amplitude is our a value, yes? What's the number in front of sine? 1, yes? So the amplitude is 1. There will always be an amplitude, even if it's just 1. Is there a vertical shift? Did the function, do we have anything in the place of k? No. So the vertical shift is no. It didn't move it up or down. The phase shift is our h value, something being added or subtracted to it, yes? Do we have anything being added or subtracted inside the parentheses? No, so the phase shift is none. So on some of these here, especially on the homework, we're not going to have something for every single line. There's only going to be some that we do. Because the only thing we really have is this division of 2, yes? Another way we can think of this is y equals sine of 1/2 times x. Of 1/2 times x. So the value of b is what? 1/2. And our period is given to us by the equation 2 pi over b. So this is going to be 2 pi over 1/2. And the 30xs will do this for us. we can plug this into the calculator, 2 pi over 1/2, and we get 4 pi. So what that's telling us is it takes it a distance of 4 pi to make one full cycle, to go one full period. And that's it. Questions on any of this here? Are you ready for the next one? This one here. So we have y equals -3 cosine of 2 pi x plus 4. Well, this one here we will have a phase shift, yes? So let's go on and factor that 2 pi out of both. Now when we factor the 2 pi out of both of these terms, we're really saying we have 2 pi times x. We factor it out of 2 pi x. We divide 2 pi x by 2 pi, which just gives us x. Now for the 4 pi, we're dividing it by 2 pi. Well, the pi and pi will cancel, and 4 over 2 is 2. Any questions on this here so far? So this makes it a little bit easier to go through these here. The period is going to be the same as the last one. We're going to take 2 pi over b. That's going to be 2 pi over, well, 2 pi, yes? 2 pi over 2 pi is 1. So the period is 1. That's going to make the period very small. The amplitude. Well, where does amplitude come from? The absolute value of the a, yes? Or the absolute value of -3, which is 3. We just grab the number that's in front of sine or cosine. We don't worry about the negative, because that negative in front of the 3 is not a part of the amplitude, it's a part of the reflection, which is telling us it's reflected across the x-axis. Now the last thing we have is phase shift and vertical shift. Our phase shift is coming from this here, this +2, yes? Now again, the normal function should have a what between it, not a plus but a minus, yes? So our 2 for our phase shift that we do have is 2, but it would be negative. We don't have to assign left or right, we can just say -2. The phase shift is -2. And what's the vertical shift? None. Because for us to have a vertical shift, we have to have something added or subtracted onto the end. And that's it. Questions on this here? Now, on the test, I will put parentheses around pretty much everything of sine and cosine. If there's not parentheses around it, so if it had, say, this +3, the +3 is not inside with x. Really what they're saying is it looks like this here. I don't like this notation because it's very tempting to put those two together, but sometimes it'll just write 2/3 sine of x plus 3, but the x and +3 are not together. Now, if we look at this here, our period is going to be what? 2 pi over b, yes? Well, what's the value of b here? 1, yes? So 2 pi over 1, which is 2 pi. Our period did not change. It's going to be the normal period for sine. Now the amplitude is what? The a value, yes? And our a value here is 2/3. Is there a reflection? No. So it is none. Is there a phase shift? No. None. Is there a vertical shift? No. None. And that's it. Questions on this here? We ready for the next one? For sine of pi x. So if we wanted to find the period, what would we do? 2 pi over pi. And 2 pi over pi is 2. So the period is 2. And that would be a lot faster than 2 pi, because 2 pi is going to be about 6.28. So it is a decent bit faster. What's our amplitude? 4. Is there a reflection? No. Is there a phase shift? No. And there's not a vertical shift. And that's it. We're ready for the next one. And this here is like one of the ones, they don't include it, but they are saying that the 1/2 x is in parentheses. Now to find the period, we're doing 2 pi over b, which is 1/2, which is going to tell us that this is 4 pi. So the period is 4 pi. Our amplitude would be 1. The reflection is none. The phase shift. Do we have something added or subtracted inside the parentheses? Nope. So the phase shift is none. And the vertical shift is 4, yes? We could say down 4, or we could say minus 4. And I'll take minus 4 for the vertical shift, because just like with phase shift, we're saying plus is going to go to the right, minus is to the left. So I'll take it for this here. Any other questions on these here? Do y'all need to see another example of one of these? Or do we feel comfortable with them? We can do a few more. Now, when we look at this one here, what is the value of b for our phase or our period? 1, yes? So the period is going to be what? 2 pi. Because if the number in front of x is 1, it's understood that the period is 2 pi. Now we need to look at the amplitude. So the amplitude would be 1. Is there a reflection? None. Nope. No reflection. None. Phase shift is what? Does it be this value here? Yes. And again, since it's normally being subtracted, so this phase shift is going to be positive a pi over 4. We didn't have to factor anything out because the period's value of b was 1. So we just take this here. So it's a phase shift of pi over 4 to the right or to the left. It's just pi over 4. And our vertical shift is none. Any other questions on this here? So what would the period for this one be? 2 pi. Because since the value of b is 1, we would have 2 pi over 1, which would just give us 2 pi. Now the amplitude is 4, because again, our amplitude is the number in front of sine or cosine. Is there a reflection? No, so it's none. Phase shift. Well, we do have a phase shift, yes? It's our 3 pi over 2, and it'd be positive because inside the parentheses it has a negative sign in front of it. And lastly, the vertical shift is none. And that's it. Questions on any of this here? So this here is the last one we'll look at. So what's the period for this one here? 2 pi, because we don't have a number in front of x besides 1. So we'll just have 2 pi over 1, which is just going to be 2 pi. The amplitude is 3. And again, we don't have a reflection. At this time, we do have a phase shift, and the phase shift would be, it is pi, but it would be negative pi. Because since we have plus inside the parentheses, it means the phase shift's amount is going to be negative. And our vertical shift is negative 2. And that's it. Any questions on any of this here? And that is it for the day.